Okay. Right. So we continue the lesson. So 8.2.4. So we're going to learn about the effect of the data changes on dispersion based on the value of measure of dispersion and graphical representation. Okay. So A, we are looking at, all right. So when each data is multiplied by a constant, then the new range, okay, will increase by the constant k, all right? So meaning that if the range is 4, okay, so the old range is 4, then the new range, okay, the new range will be 4 times k. So if all the data, let's say x1, original x1, x2, x3, and so on until xn, so we multiply by k. So you get kx1, kx2, kx3 until kxn. So we will have the same, sorry, I have a new range that is k, right? So you can see here kxn minus kx1, right? So it's k times xn minus x1. So if the all data is xn minus x1, so you can see here the new range will be increased, right, by multiplication of the range or all range times the constant. Okay, if the new interquartile range will be the same as the range, okay, so because you multiply k, right, so the first quarter and third quarter will be increased by k, right, multiplication of k. So the new IQR, okay, the new IQR will be the same, right, not the same, my will increase by 4 IQR lah. Okay, so this one is by set IQR, so it's 4 IQR, right? So okay, so if k multiplied by k, so it's k, okay. So if new standard deviation also the same, so all standard deviation, so new standard deviation will be k times sigma, right? The all sigma. The variance will be different because you square it, therefore is k times sigma square, right? So remember, only variance is square. So if you divide all the data with a constant k, then all the new range, okay, new range, new interquartile range standard deviation will be divided by k. So if I set the original range is a, so the new range will be a over k. So if the original interquartile range is b, then the new k, the new interquartile range will be b over k. Standard deviation also same, sigma over k, but the variance will be sigma square over k square, right? If you add it, right, if you add numbers, the data, if you add the data x1 plus 2, okay, let's say here, until xn plus 2, so you can see here xn plus 2, the range, if you say this is the smallest data, this is the highest data, so xn minus x1 plus 2, so you get xn minus x1 because 2 and 2 cancel out. So meaning that if you add or you minus each data with a constant, it won't affect the range, the interquartile range, the standard deviation, or the variance. Or we can say that the measure of dispersion will not affected by addition or subtraction of each data with a constant. Okay, but it will affect the measure of dispersion if you multiply or you divide. Okay, so this is the first thing that you need to know. Then A, if there is an outlier, okay, if an outlier is added or removed from the set of data, the range will change dramatically, right? The interquartile range will less affected if outlier is added or removed from the data. So this one we've learned already, in previous 8.2.3, the effect, and then the variance and standard deviation will increase. You see, variance and standard deviation will be increased significantly when an outlier is added into the set of data. So the difference, okay, so the difference between the new value of data, okay, sorry about that, right, and the mean is small when the new standard of deviation is smaller, and vice versa, right? So that's mean is smaller, right? If the different, the new value is of the data is the difference between the new value of the data and the mean is small, then the standard deviation will be smaller and vice versa. It's bigger than it's a big the standard deviation will be increased, meaning that, okay, if the mean is let's say is 4, then we add on outlier. Okay, outlier is, let's say outlier is x0 is 0.01. So the difference here is quite big, right? It's 4 point something, 3.99 something, 99. Okay, then the standard deviation will be affected. If our outlier is let's say is 3, then our standard deviation will be smaller. This one, the standard deviation will be bigger, right? Compared to this, the difference. That means the difference here, if bigger, then the standard deviation is bigger. If the standard deviation, the mean and the outlier is the difference is smaller, then the standard deviation will be smaller. That is quite logic, quite logic, right? I mean that. So if you remove remove or you add the new data in, let's say we said outlier, the difference is big, then the standard deviation will be big. If the difference is smaller, then the standard deviation will be smaller. So it's the same, okay? So meaning that if there's outlier, right? Outlier. If there's outlier, the best measures of dispersion is interquartile range, right? So the range and standard deviation will change dramatically, right? So we increase dramatically, so meaning that the range, so is xn and x1. So we either the outlier is xn or x1, that means more than xn. So if the xn, if the let's say the smallest data is 1, right? The biggest data is 10. Then our outlier is 100. Therefore, you see the range will become 99. So wow, this one is only 9, right? So if you have an outlier here is 0.01, then you can see here, right? The difference here is very big also, right? You can see here, right? 10 minus 9.99. This one is 9. So you compare, right? So the range will be will change also dramatically, right? So the word is dramatically. Okay. So now we go to, right, example 10, right? Okay. So given a set of data 4, 6, 7, 7, 9, 11, 12, 12, right? Calculate the standard deviation of the set of data. Hence, calculate the new standard deviation. When 4 is removed, 7 is added, 18 is added, and all the data is subtracted by 2 and divided by 3. So first thing, we find the standard deviation, right? First. So the SD lah. So now we find the mean first. 4 plus 6 plus 7 plus 7 plus 9 plus 11 plus 12 plus 12, and then you divide it by, okay, 1, 2, 3, 4, 5, 6, 7, 8, right? So divided by 8. Okay, so you can use your calculator. 6 plus 14 plus, okay, it's 68, 68 over 8. Then you find the x square. So it's 4 square plus 6 square plus 7 square plus 7 square plus 9 square plus 11 square plus 12 square plus 12 square. Okay, so equals to, let's see, square. So if you are still not familiar with the formula, you do it slowly. Huh? So you get 640. Okay, so standard deviation is sum of x squared divided by n minus the mean square, right? Then you square root it. So we put in all the value in 640 divided by 8 minus 68 over 8 squared. So you get the value minus 68 over 8 squared. So it gets 2.78, right? 2.7839, right? So it's roughly is 2.784. Okay. So if 4 is removed, so what happened to this? So 4 is removed. What is the mean? Mean, right? Okay, we find the mean first, 68 over 8. So it's 8.5. So 8.5 the mean. So you see the difference is 4 here. So your standard deviation will also decrease. Right? So let's see how. So now our mean is, okay, so original is 68, right? So the new mean is now is 64 divided by 7. Okay. And then our sum of square, so A. So we cancel out the 4 square, there will be 640 minus 4 square. Okay, so it's 640 minus 4 square, so you get 624. So what is our standard deviation? Okay, square root of 624 divided by 7 minus 64 over 7 square. So you use your calculator. All right, 624 divided by 7 minus by 64 over 7 square. So you get 2.35. 356. So it's the difference is about 0.4. Okay. So now we go to B. If 7 is added, 7 is added in. So this one is removed. We added in 7, so it's 1.5. So it's not much difference. Okay, so not much difference. So it's around 0.1 maybe. So let's see. Okay, so now our sum will, sorry, this one is mean. I used the wrong. Okay, mean. The new mean is 68 plus 7 divided by 8. So 68 plus 7 is 75 over 8. And then our sum of square is 640 plus 49. So it's 689. So our standard deviation is, right, sum of 689 divided by 8 square, then minus 75 over 8 square. So you can see here 689 divided by 8. Okay, so I think I wrote wrongly here. No square here. Minus 75 over 8 square. Oops. Hmm. 689 divided by 8 minus okay, maybe there's something wrong. 7 is added. Okay, so something wrong. Huh? Okay, sorry. When you add is no wonder. Sorry. Okay, this is the mistake here. No wonder. This is 9. Okay. .67, right? So roughly 0.1, just now I said, so 667, So if 18 is added, so you can see here, just now we add 7 in, so the mean here is 8.5, right? The mean is 8.5. So the difference here is 4.5, right? Difference. So now this one difference is only 1.5. Okay. So now this one, the difference is a lot, right? So it's 17, is 10.5. So here will be increased, right? Okay. So here will be increased. So let's see. Okay, let's go to C. All right, C. So our mean is, okay. So mean will be 68 plus 18 divided by 9. Okay. Right, so it's 86 over 9. Okay, our sum of square is 640 plus 18 square. So it's 640 plus 18 square, so you get 964. So our standard deviation will be 964 over 9 minus 86 over 9, and then you square it. Then you square root. All right, so it's square root 964 divided by 9 minus 86 over 9 square. So it is 3.975. 975. So you can see here the difference is 0.1. Right? It's 1.2. Right? 1.2 like that. Right? Or it's 1.1 because of this 10.5. So the difference is increased by 1.1. So if you 1.5, so increased by 0.1, right? Or minus. This one 4.5, right? So difference is minus, then you minus 0.4, right? Okay, so now, so you can see, if the data is removed or added, is the difference with the mean is smaller, then the standard deviation will be decreased or increased with small value, point something. But if you increase by a lot, it's 10 and above, then your standard deviation also increase by 1 point something. Okay, so that's not so important. The important that you know that is the difference is bigger. The data, the outlier you put in, is not the outlier, it's a data you put in is, if the difference is with the mean is very big, then the standard deviation will change in great value. Okay, then we go to D. Now all the data subtracted by 2 and multiplied by 3. So, okay, so now is every data with plus 2 subtracted by 2 and multiply divide by 3, right? So that's mean 4 minus 2 divided by 3. Then is 6 minus 2 divided by 3, 7 minus 2 divided by 3. Okay. 9 minus 2 divided by 3. 11 minus 2 divided by 3. 12 minus 2 divided by 3. Okay, so this is the new data. So what is the mean then? Okay, so the mean, right, mean, so it's 4 minus 2. So it's 640. You can see here 640. Sorry, this one is divided by 3. Okay. Sorry, 68, right? 68. You minus 2, 1, 2, 3, 4, 5, 6, 7, 8, right? So it's 68 minus 2. 2 times 8. Then you divide it by 3, right? So it's divided by 3. Everything is divided by 3, right? So divide by 3. Right? Okay. And then you divide that by 8. Okay, so let's see correct now. Huh? 2 over 3 plus 4 over 3 plus 5 over 3. Oops. Sorry, 2 over 3 plus 4 over 3 plus 5 over 3 plus 5 over 3 plus 7 over 3 plus 3 plus 10 over 3 plus 10 over 3. So it's 52 over 3. Okay, 52 over 3 divided by 8. So it's 13 over 6. Okay, let's check just now. 68 minus 2 times 8 divided by 3. Right, then divided by 8. Correct? Huh? So it's this. So you want the shortcut is this. Then I want to find my sum of square. Okay, this one we have no choice. So we do Dong long way. 2 over 3 square plus 4 over 3 square plus 5 over 3 square, 5 over 3 square plus 7 over 3 square plus 3 square, right? 9 over 3 is 3 square. So plus 10 over 3 square plus 10 over 3 square. So we want to find out what we have studied, we have learned from here. That is, if the standard deviation, if divided by 3, all the data divided by 3, we add a number. So it will only affect if you divide the division part. Okay, so that means the standard deviation should be divided by 3 from the original standard deviation. That is 2.784 divided by 3 later on. Okay, let's see. Right, 2 over 3 square plus, right, plus so I get 400 over 9. Okay, so our standard deviation is 400 over 9 over 8, okay, minus 13 over 6 square. Okay, so let's see. 8, yes. Okay. So you get 0.928. Okay, so it's 2.784 divided by 3. Okay, so it's equivalent to 2.784 divided by 3. That is standard deviation. The old one, you divided by 3. Right? Sorry. So here. Okay. So this is standard deviation. The old standard deviation, you divided by 3. Okay. So that's been it proved that when you subtracted by 2, you divide by 3. So the standard deviation will be affected by division of 3. Okay, so the standard deviation new standard deviation will be 3, the third, 1/3 of the old standard deviation. Okay, so let's see number 2. Okay, understand? Huh? Okay, let's see number 2, mean. The mean of a set of numbers 2y, 5, 2y plus 1, 10, and 12 is 7. Find the value of y and then the variance, the mean. So you can see here A is mean. Okay, mean. So what we do, we use the formula. Mean is the sum of the data divided by total data. So it's 7, then 2 plus y plus 5 plus 2y plus 1 plus 10 plus 12 divided by 1, 2, 3, 4, 5, 6. Okay, so you get 2 plus 5 plus 11 plus 12. So is 3y plus 30 divided by 6 equals to 7, right? So 3y equals to 42 minus 30. So it's 12. Therefore, y is 4. Okay, this is A1. So A2, find the variance. So the variance is the sum of, we just find the sum of x squared because we already know the mean. Mean is 7 here. So therefore, it's 2 squared plus y is 4 square. Here is 4. Here is 2 times 4, 8. 8 plus 1, 9. Right? So plus 5 square plus 9 square plus 10 square plus 12 square equivalent to so 370. So our variance, so is sum of x squared, data square divided by n times minus the mean square. Therefore, it's 370 divided by 6 minus 7 square. So divided by 6 minus 7 square. So it's 38 over 3. Or is 12.67. Okay. So B, if each number is multiplied by 2 and then 2 is added to it. So we use the info, what we have learned just now. So if multiply by 3, and 2 is added in, so this one is not related. So we use red color, that means not related. So our mean is very easy. Our mean will be multiplied by 3. So the new mean is 3 times 7, 21. Standard deviation, so is 3 times the old standard deviation, that is 38 over square root of 38 over 3, right? So you square it, then you times 3. So you get 10.67 or 10.68. So this is the standard deviation. So why we square root here? Because this is variance. Standard deviation is sigma, right? Sigma is, so you want to get the sigma, then you square it, square root it, right? So this is number 2. So you do the exercise, self-practice at point 2D, page 234. Right? So that's all for this video.